That's one way to multiply vectors. The next way to multiply vectors together is with the cross product. Okay, so here's the definition. If we let a vector u equal u1, u2, and u3, and we let v equal v1, v2, v3, then the cross product is defined as a 2 by 2 determinant using u2, u3, v2, v3 times the unit vector I minus the determinant of u1, u3, v1, v3 times the unit vector j plus the determinant of u1, u2, v1, v2 times the unit vector k. Moving on. No, just kidding.
Do you know why it's minus plus or no?
That's just the way it's defined. There's nice shortcuts that you learn in math team, I'm sure. But I can tell you that this technique will work for any size. Well, I guess I can show you the matrix and the linear algebra behind this. But if it was bigger than a 3 by 3 or a three-dimensional vector, you'd have 4 of these. This would be a 3 by 3 determinant, and then you just go minus plus. It always alternates.
Can we go over matrices again?
We will in DiffyQ. But you want matrix help now? Oh, okay. Do we know what a determinant is? Okay, let's write it down. The determinant of a matrix A. And this is assuming, let's just say A is A1, A2, A3, A4. The definition for a determinant of a 2 by 2 matrix, you do the product of A1 and A4. So you just multiply that away, and then you subtract A2 minus A3. So that's what this stuff up here means, because the other notation is to write A with what looks like absolute value signs, but it's actually the other symbol for determinant. Okay. I have a feeling you did this in 8th grade, most of you?
Yeah.
With your calculator? Okay. Now, do we know how to do 3 by 3 determinants? I'm going off script here, but this is going to help us. It'd be great if you did. Okay. A 3 by 3 determinants. Let's say.
Is determinant another word for matrix?
No, determinant is an operation performed on a matrix. The cross product is up here. Okay. A lot of you seem to be confused with this. So I'm trying to review a little bit of matrix stuff that you guys have seen before, maybe going to 3 by 3, maybe you haven't seen that before, but once we do this, we'll have an easier way of doing that without having to remember all this stuff. Okay? This. A determinant is used to find like the inverse of a matrix. That would be one application of it, but we're not going to even get there till DiffyQ. What we're doing here with the determinant, why am I introducing this, right? Because it's going to help us come up with a better way of remembering how to calculate this. Okay? Let's say A is a 3 by 3 matrix, and you know what? So I don't have subscripts. I'm just going to go alphabetical here. A, B, C, D, E, F, G, H, I.
Where are the numbers?
Okay, I'll explain it once, and then I think it'll be easy to remember. The determinant of A, you simply start by taking first entry in the first column, which is A. You just write it down. And then now you eliminate, so this is how I remember it. You eliminate first row and first column, and what's left? E, F, H, I. Write it down and put it inside a 2 by 2 determinant. Okay? And then you take the next entry in the first row, and we always do the opposite of that. And now, using the same technique, eliminating the first row and the column that B is in, now we have what left? D, F, G, I, so write it down, inside a 2 by 2 determinant. And then you repeat, you go to the last entry, which is C, and now we alternate signs, and then we do the same thing. Eliminate first row, last column, and now we have D, E, G, H. And this method for finding a determinant for a 3 by 3, we're not going to do it, but will work for 4 by 4s, 5 by 5s, and so on. It's just here at this step, this would be a 3 by 3 when you did it. Does that make sense? And then you'd have to take 3 by 3 and do it again. So, not the most convenient way of doing it, but for us, this is going to be very easy, I promise. Okay? So, can you guys remember this?
Just the first row, or do you do...
Just the first row for the coefficients. The first row are going to be the coefficients of the little 2 by 2 baby determinants. Okay? Now, here's what I'm going to show you. Let's go back to U cross V, because this is ultimately what we need to figure out. Okay? And memorizing this formula is kind of long and not so much fun. However, if you use this notation and make a 3 by 3 determinant where the first row is I, J, and K, and then the second row, you just put the first components, let me rephrase, you put the components of U in this middle row, so U1, U2, U3, and then for this last row, you put the components of V. Watch what happens. If you just remember what this means, right? Think about how we did the determinant. Instead of putting the I first, I'm going to put it at the end. Is that okay with everybody? And then we do the same thing. Eliminate the row, eliminate the column. What's left? U2, U3, V2, V3, and look at that. That's exactly the first part of the definition. Okay? If we alternate the next step, now we have a 2 by 2 times what unit vector? J. And now eliminate this row and that column. We get U1, U3, and V1, V3. And I'm out of space, so I'll just go here. Plus, do the same thing with K. And now we have U1, U2, V1, V2. Okay, so ultimately, here's the definition for cross product. But this is a much easier way to remember how to calculate it. Okay? Say that again? Yes. Okay. Now, here's what I want you guys to try out, just to get used to this. Let's let U equal I minus 2J plus K. And let's let V equal 3I plus J minus 2K. Go ahead and calculate U cross V. And then go ahead and do V cross U. And then go ahead and just do V cross V. done here in about 7 minutes. Just to make sure, if you're setting up the first one correctly, it should look roughly something like this. And then now you just do each little determinant. So 4 minus 1 is 3. That's the first component. Here we do -2 minus 3, which is -5. However, there's a negative here, so it becomes 5. And then we do 1 minus -6, which is +7. So the first cross product should be 3, 5, 7. And just to save a little bit of time, has anybody done the second one yet? It's just the opposite. -3, -5, -7. Has anyone done the third one yet? All of them are 0, right? Okay. So a couple things this leads us to, some properties. 1. U cross V does not commute. It's not the same as V cross U, but it is the same as the opposite of V cross U. Let's see, another observation. If we take a cross product of a vector with itself, we get the 0 vector. Okay, we're going to fill in more properties tomorrow, but here's what I want to end with first. So we'll come back to this. Now, if we take the dot product, real quick, of, let's say, U with U cross V. So let's just use the example we calculated here. So our U is 1, -2, 1. I'm going to dot that with my answer for U cross V, which was 3, 5, 7. And oh, why not? Let's do that also with the other vector, V with also U cross V. Take the dot product. What was V? 3.
3, 1, 2.
Okay. The reason I want you guys to do this real quick, if you take the dot product of this one, you get 3 minus 10 plus 7, which is 0. Here you get 9 plus 5 minus 14, which is 0. If the dot product of two vectors are orthogonal,
Zero. Then arrow.
if they're 0, then the vectors are orthogonal. So what this means is that the cross product gives you a third vector orthogonal to both original ones. Does that make sense? Okay, and we can talk real quick about the direction, and then we'll finish up with some properties and do some more work with this tomorrow. Okay? We use the right-hand rule, again, to determine what the direction is. And here's how it works. Let's say, I'll do a very quick example here. Let's say this is I. Let's say this is J. And let's say this is K. And I wanted to calculate I cross J. Okay? Here's how the right-hand rule works. So you got to kind of visualize this. You take the first vector, which is I. You curl your fingers in the direction that you're crossing of the vector you're crossing it with. So you think of it as this. So if you curl your fingers towards J, can you guys do that real quick? Which way is it pointing? Up. So what's this going to be? This is going to be K. Okay? We can do more with the direction later on. But that's essentially how it works.
I really did not get that, what you said.
The right-hand rule?
Yeah.
Here, let me explain it with meter sticks.